Okay, so let's take a look at this assignment. So the key here for 1 through 6 is using this rule. So if I look at number 1, that would become the 5th root of 2 to the 3rd, and you could just leave your answer like that is fine. If you wrote it as the 5th root of 8, that's okay too if you did that, no big deal. Any questions on 1 through 3, if that's really all you need to do? Similarly on 4, 5, and 6, so I'm just going to do the same thing, and that's going to become 5 to the 7/3. Everybody's okay with that? So that's all you really need to do for 1 through 6 was just practicing converting back and forth. I didn't need you to do any simplifying or rearranging or anything like that. It was just converting from one form to the other. If you did those things, that's fine, like simplifying or any of those like extra steps, that's okay, but you didn't really need to do it. You're just doing too much kind of thing. Okay. So let's look at some of these here. So we'll start with just number 7, which is a fairly straightforward one. So the first thing I would do is I noticed that the base on the exponential 27 to the 1/4, that 27 isn't prime, right? So the first thing I would do is I would rewrite 27 as a prime factorization. 27 is 3 to the 3rd. Is everybody okay with how I did that? Now, when I have an exponent of an exponent like that, how do I simplify a situation like that? I have an exponent of an exponent. This is one of our properties. Okay, remember that list of properties I said was very important that we have memorized. So when I have an exponent of an exponent, they multiply. So what is 3 times 1/4? 3/4, right? So that's going to become 3 to the 1/4 times 3 to the 3/4. Everybody okay there? Now I notice that my exponentials have the same base. Each of them has a base of 3. So I can multiply these together. How do I multiply exponentials when they have the same base? By adding their exponents. So what is 1/4 plus 3/4? 1. And that's as good as you can do. Okay. Should we do another? Harley? Which one? 12. Sure. So I'm going to start the same way, and I'm going to start with doing a prime factorization. So the prime factorization of 144 is 2 to the 4th times 3 to the 2nd. And then I need to do a prime factorization of 384. What, do you have it? Ah, thank you. And that I can't do in my head. So let's see, 1, 2, 3, 4, 5, 6, 7. So that's 2 to the 7 times 3. And we're all okay doing the prime factorizations, right? Now, to combine these two different kinds of radicals, I have a third root and a fifth root. I need to rewrite these in the exponential form. So the cube root of 2 to the 4th is really 2 to the 4/3. The cube root of 3 squared is 3 to the 2/3. The fifth root of 2 to the 7th is the 2 to the 7/5. And the fifth root of 3 is 3 to the 1/5. So here's the 3, there's the 2, and there's the thirds. Is that okay? Okay. So for these exponentials, I can multiply them together if they have the same base. So I can multiply the base 2 exponentials together, and I can multiply the base 3 exponentials together. When I multiply exponentials, I have to add their exponents. So I'll have 2 to the 4/3 plus 7/5, and then 3 to the 2/3 plus 1/5. Is everybody okay there? To add those fractions, what do I need to have? A common denominator. What would be the common denominator between thirds and fifths? 15ths. So the 4/3 I'm going to multiply by 5 over 5 to give me 20 over 15. And the 7/5 I'm going to multiply by 3 over 3 to give me 21 over 15. Similarly, the 2/3 I'm going to multiply by 5 over 5. And the 1/5 I'll multiply by 3 over 3. So that's going to give me 2 to the 41/15 times 3 to the 13/15. Is everybody okay there? I have one more thing to take care of, and it's this: I have an improper fraction here. So to deal with that, what I'm going to do is I'm going to rewrite 41/15 as a mixed number. So 41/15 is really 2 and 11/15. Everybody agree with that? It's going to be 2 to the 2 plus 11/15. Which is going to be then, if I break this up, 2 squared times 2 to the 11/15 times 3 to the 13/15. And last step now is to put this back into radical form, only because the direction says to write our final answer in the same form as the starting problem was. So I have my 2 squared, or 4, and then I have the 15th root of 2 to the 11th times 3 to the 13th. And I'm going to leave that in exponential form. because that very likely is going to overflow your calculator. Those are some pretty absurdly large numbers, so let's just leave them in exponential form. You're welcome to do that for any of these kinds of problems. If you have something that's going to be very large, you can just leave them in the exponential form like we've done there. You don't need to multiply out 2 to the 11th times 3 to the 13th. Did it overflow your calculator, Harley? Did it give you scientific notation, though? It didn't? I'm shocked. Let's check. Oh, I guess you're right. I'm surprised. That's still a silly number to write down. I'll just leave it in the exponential form. But if you wanted to, you could put that number underneath the 15th root. Yuck. Did that help though, Harley? Seeing that go through? Should we do another? Sure. So how should I start? Yeah, prime factorizations. So 12 is 2 squared times 3. 24 is 2 to the 3rd times 3. 48 is 2 to the 4th times 3. And 96 is 2 to the 5th times 3. Everybody okay there? Notice that because we contain different kinds of radicals, to manipulate this with the multiplication and division, I need to write this in exponential form. So I'm going to have 2 to the 2 over 2, which is just 2 to the 1st, so I'm just going to leave it there, times 3 to the 1/2, times 2 to the 3 over, which is just 2 to the 1st, times 3 to the 1/3, and then similarly 2 times 3 to the 1/4, and then times 2 to times 3 to the 1/5. Is everybody okay with how I converted that out to exponential form? Madison, what's up? So, well, the first 2 is really 2 to the 2 over 2, which is just 2 to the 1st, which I can just write as 2, right? Well, 2 to the 4 over 4, 2 to the 5 over 5, so they're just all just 2 to the 1sts. Is that okay? Okay. So again, I skipped that little reducing step, but it's one of those where when you look at it for a second, it should be clear. If you need to write it down, surely write it down. It's no big deal. If it helps you, that's not a big deal. Now what I notice is I can do a little reducing, right? So these 2's on top and bottom can cancel. Everybody's okay there? So when I multiply exponentials, what do I do with their exponents? If I multiply exponentials with the same base, we add their exponents. And then when I divide exponentials with the same base, what do I do with their exponents? We subtract. It's the same thing as subtracting them individually because you distribute the negative after you add them. So Madison, what you're saying is, can you do this? Yeah, it's the same thing. Because the negative sign distributes. and you're going to end up with the same thing I have up there. It was just less symbols to write for me to write it that way, but it's not wrong to think about it the way that you've described. You'll get the same answer. Is that okay? All right. The advantage of writing it the way that I'm doing is I only need to find a common denominator once, because I'm just going to find one common denominator for 2, 3, 4, and 5, which I think is a little less work than doing 2 common denominators, but not much. Or really 3 common denominators, I guess I should say. But it just felt like it was going to be a little bit less. But it doesn't really matter. So if I want a common denominator for halves, thirds, fourths, and fifths, that would be you just need a number that's divisible or can be divided by each one of those 4. So I think 60 is the least one. 60 is divisible by 2, 3, 4, and 5, so that'll work. So what do I need to multiply 2 by to get to 60? 30. So that's going to give me 3 to the 30/60ths. What do I need to multiply 3 by to get to 60? 20. So that'll be 20/60ths. What do I have to multiply 4 by to get to 60? 15. So that'll give me 15/60ths. And then what do I have to multiply 5 by to get to 60? 12. So I have 12/60ths. So 30 plus 20 is 50 minus 15 is 35. And then minus 12 more is 23. And then that's fine since it's a positive exponent and it is a proper fraction. The last thing I need to do is just put it back into radical form because the directions say to write your final answer in the same form as the starting problem. So that's just the 60th root of 3 to the 23. And if you wanted to, you could type 3 to the 23rd into your calculator and turn that into a decimal if you were so inclined. But you don't have to. Writing it, keeping it in the exponential form is perfectly fine. Does that feel a bit better? So they're usually not so bad, but you really have to be comfortable using those rules for exponents, right? Olivia? 9? Okay. So the first thing that I would deal with is I notice when I look at the basis of my exponential that 16 is not prime. So I would start by doing a prime factorization of 16. That's 2 to the 4th. Now recall we mentioned earlier that if I have an exponent of an exponent, we multiply those 2 exponents. So 4 times 5/9 is 20/9. Okay there? Now when I do an exponent of a product, I have to apply that exponent to each piece of the product, or each factor of the product, I should say. That's the term. So there's that. Are you okay with that, Olivia? Okay. And notice again, I have an exponent of an exponent, right? So that's going to be 2 to the negative 20/3 times 5 to the negative 9/3, or I'm sorry, 7/3, negative 7/3. We okay with what I did there? So I reduced at the same time as multiplying. So like negative 60/9 reduced down to negative 20/3. Yes? Everybody else can see that? Okay. Again, if you need to write out that extra step and do the reducing, that's fine. Please do that if it helps you. I don't need to see it, but if it helps you, you can do that. or should do that if it helps you. So now I have these negative exponents. What does a negative exponent mean? It means a reciprocal, right? So what I'm going to do is I'm going to write this as 1 over 2 to the 20-thirds times 5 to the 7/3. And now I have two issues, right? I have improper fractions. 20-thirds and 7/3 are both greater than 1. And I also have fractional exponents in the denominator. Remember that a fractional exponent is really just the same thing as a radical. So a fractional exponent in your denominator is just like having a radical in your denominator, and we didn't like that either. Which one of those should I address first? The improper fraction or the radical in the denominator? I would do the radical in the denominator first, because if I do that first, it's going to take care of the improper fraction at the same time. If you do the improper fraction first, you're still going to have to do the radical in the denominator step. So it's like saves you a step by doing it in the other order. So in general, the last thing that I'm ever going to worry about is the improper fraction. I'm going to deal with negative exponents and fractional exponents in the denominator before the improper fraction. Is that okay? So to deal with that, I'm going to look at this exponent, 20-thirds. What's the next whole number after 20-thirds? Would be 21-thirds or 7. Everybody agree with that? So if I'm at 20-thirds now, how many more thirds do I need to get to 21-thirds? 1/3 more. Everybody agree with that? So I'm going to multiply the top and bottom of this fraction by 2 to the 1/3. Now I'm going to look at the 7/3. What's the next whole number after 7/3? 9/3 or 3. We're at 7/3 now. How many more to get to 9/3? 2/3 more. So I'm going to multiply the top and bottom also by 5 to the 2/3. Everybody okay there? So I'm going to have 2 to the 1/3 times 5 to the 2/3 over 2 to the 7th times 5 to the 3rd. And if I look now, I have no improper fractions in my exponents, no fractional exponents in my denominators, no negative exponents. Everything that I can combine has been combined without having to undo something. So this is going to be my final answer here. Oh, and because we started in exponential form, I left my final answer in exponential form, per the directions of the problem. Is everybody okay with that one? Probably have time for one more if you'd like to do one more. Madison? What is them? So you're talking down here at the end? No, at the beginning of the because these are different kinds of radicals. If they were all square roots, then you could put it all together under one square root. And then you could deal with it from there. Yes, but the fact that they're all different, you cannot do that. You can put it all under the same and multiply the 12 and 24 together and the 48 and 96 together and reduce, and then do a prime factorization, and it'd be really quick. But they're not. They're all different, so you have to use the fractional exponents. Is that okay? Good question, though. That's very important. Sure, we can do 14. So just like before, I'm going to start with prime factorizations. So 40 is 2 to the third times 5. And then 567 is 3 to the fourth times 7. So I'm going to convert this into exponential form. So that's 2 to the 3 halves times 5 to the 1 half over 3 to the 4 thirds times 7 to the 1 third. Everybody's okay here? Notice that none of these exponentials, none of their bases are the same, right? I have base 2 and 5, 3 and 7, so nothing is going to get to combine together. All I have to worry about here is just the form of my answer. So there's two things that I'm going to worry about. I'm going to worry about fractional exponents in my denominator and then improper fractions in my exponent. I'm going to do the exponents in the denominator first. So the first whole number after 4 thirds is 6 thirds, or 2. So I'll multiply the top and bottom by 3 to the 2 thirds. And then I'll look at the next exponent. The next whole number after 1 third is 1, or 3 thirds. So I need 2 thirds more here also. So when I multiply this together, I'm going to get 3 squared times 7 on the bottom. We okay to hear? Now I do have one improper fraction rattling around here. That's the 3 over 2. So I'm going to go ahead and write that as a mixed number. That's the same thing as 1 and 1/2. So I can write that then as 2 to the first times 2 to the 1/2, 5 to the 1/2, 3 to the 2 thirds, 7 to the 2 thirds, all over 3 squared times 7. And then the last thing I want to do is I want to get this stuff all under the same radical, because the directions say to write in the same form as what I started, right? The problem is if I look at my exponents, I have different denominators. So I'm just going to make one common denominator, but I'm not going to be able to add any of these exponents together because the base on the exponentials is all different. But I need to get them with the same denominator in the fraction so I can put them under the same radical. So the common denominator between 2 and 3 is 6, right? So I'm just going to write this one as 3/6, 3/6, 4/6, and then 4/6. So I'm going to have 2 times the 6th root of 2 to the third times 5 to the third times 3 to the fourth times 7 to the fourth over 3 squared times 7. And if you wanted to, you could multiply some parts of that out or all of those parts, or you can leave it in this, prime factorization form. Any of those is fine. usually on these problems, I just leave them as prime factorizations because it's convenient. I don't have any to get out my calculator and multiply all that garbaggio together. Julie, are you happy with that? So it was a kind of a weird problem, as there's not a lot of combining to do, right? You just had to get it under the same radical and get the exponents out of the denominator and all that. Also worth saying, the order in which I'm doing things on these problems, is it set in stone? Not really, right? You could worry about doing, like getting rid of the improper fractions before getting the exponents out of the denominator or something like that. I just try to look at things as like the quickest way to do the problem. So oftentimes if you thought to do something differently, it may be perfectly fine. It could be equivalent, or it might be a little bit more work, but it's probably still okay. As there's lots of different ways to approach these problems in terms of what steps to do in kind of what order. So don't feel like, oh, I didn't do this the same way Mr. Kulik did. I got the same answer as him. I wonder if my way is wrong. Might not be. Could still be fine. But usually just what I'm looking for is the kind of the shortest way to do these when I'm trying them. Okay with that? Okay. Let's move on. So the next thing I want to start talking about is solving radical equations. So there's kind of two things to keep in mind. So the first thing is when you're solving, yes, Kate? Sure. And you take the even root to both sides of an equation, that generates a plus or minus. So for example, if I have x to the fourth is equal to 16, and I take the fourth root to both sides, I get that x is plus or minus 2. This does not happen if you're using an odd root. So if I am taking the odd root to both sides, the cube root of 8 is just 2. Okay, so we have the first place to be careful is you have to remember or pay attention to whether you're taking the odd root to both sides or the even root to both sides, because that makes a big difference. Is everybody okay with that idea? There's no plus or minus, just whatever it is, it is. It's okay with that, Madison? Okay. The second thing is, The second thing that we have to remember is if I'm solving a problem with an even root in the problem, I have to make sure that I'm checking for extraneous solutions. Remember, we've seen extraneous solutions happen a couple of times before, in particularly when we dealt with absolute value equations. It was possible that we get an answer that doesn't actually work. You guys kind of remember that? So the same thing can happen here when we're dealing with equations that involve even roots. We have to make sure that we're stopping and checking our answers when we're done, because it is possible to get an extraneous solution. And we'll see some examples later on, not today's lesson, but the next day's lesson, where that'll happen. Okay? So let's look at some examples now. So let's say we have the cube root of 2x plus 7 equals 3. What would I want to do first to solve this problem? So it's just like any other standard solving problem. The first thing that I'd want to do is to try to do the reverse order of operations. So if I was doing the order of operations, the first thing I would need to do is do the things underneath the square root sign, right? And then do the square root sign after that. Or the cube root, excuse me, the cube root sign, right? So the first thing I should do when I'm solving is try to get rid of the cube root symbol. What can I do to both sides of this equation to cancel the cube root symbol? Use the reciprocal. What operation is going to cancel out a cube root? Sure you do. What would cancel out a square root? Squaring, right? What's going to cancel out a cube root then? Cubing. So we're going to cube both sides. And 3 to the third is 27, so I'll just write the 27 there. Worth pointing out there, common mistake I see students make, in particular in this class, is they multiply 3 times 3 rather than doing 3 to the third power. So please be careful with that. Exponents and multiplication are not the same thing. Why didn't I have to make a plus or minus here? Oh, never mind. There's no. There's nothing to worry. That's a stupid question. Anyways, continuing on. Next thing I should do is subtract 7, right? It's easy from here, right? And then the last thing is to do what? Divide by 2. And we don't need to check this answer. Why not? What kind of problem, what kind of radical does this problem have? An odd root. right? We only need to worry about checking as if we have a even root. Let's say we have, yes, Michael? Sure. Say we have this problem. 2 times the fourth root of x plus 6 minus 5 equals negative 3. What would we do first on this problem? Well, not yet. I would do something before I worried about the 2. Add 5. Is that okay with everybody? Now what? Divide by 2 is correct. And now, Sierra, it's time to do the exponent of 4 to both sides. Everybody's good there? My last step would be to subtract 6. Am I done? No. Very good. We need to check. Why did we need to check on this problem? It's an even root, right? Yep, the index tells you whether it's odd or even. That's the little number in the check mark. So if I do that, it does work. So you don't have to show your checks for me. I'd be fine with just putting a check mark next to your answer, indicating to me that you did try to check it. But you don't need to write down your checking. You can do it on your calculator or whatever. It's fine. Not a big deal. But make sure that you're doing that. Is everybody okay so far? Good. Let's look at another one. Let's say we have 4 to the 2/3 is equal to 36. What should I do first on this problem? Well, I'd want to do something before I worried about the exponent. I would want to divide by 4 first. Yep. Remember that exponent is only attached to the x, it's not attached to the 4. So we need to get the 4 out of there first. Is everybody okay with that? Okay. Now, Madison, you're right on in that we want to cancel out that exponent of 2/3. The problem is that radicals, that index on the radical needs to be a whole number. So we can't use a 3/2 or 2/3 root here. That's not okay. But what we can do is we can do the exponent of both sides. So what exponent would cancel out the 2/3? So when I have an exponent of an exponent, what happens to those two exponents? We've said this like 3 or 4 times now today. Do you guys remember? What do you do if I have an exponent of an exponent? They multiply, right? So we want that x to end up as x to the first, right? So what can I multiply to 2/3 that's going to give me 1? What? Well, 1/3 times 2/3 is going to give me 2, right? Or no, that'll add to give me 1. I need it to multiply to give me 1. Excuse me. I need to use its reciprocal. 2/3 times 3/2 is 1, right? But we have to be very careful here, because what did I really do to both sides? I took the square root of both sides. Remember that a fractional exponent is equivalent to a radical, right? Where the denominator is the index of the radical. This is really me square rooting both sides.
Okay, but that's just coincidental that the 9 so happens.
The 9 has nothing to do with it. And a 9 is just a happy coincidence. Yeah. And then the 9 to the 3/2 power is 27. I did that in my head. You could type that in your calculator, though, if you needed to. But it's doable by hand. It's not hard to do by hand. Is everybody okay there? Do I need to check it? That's a great question. Well, if I look at the original problem, the denominator of the fraction tells me the index. Since this is an odd root, I do not need to check. That can be my final answer. Is everybody okay there? Probably have time for one more. Let's do one more. So let's say we have x plus 3 to the 2/3 plus 3 equals 7. Subtract 3 from both sides to start. That's a good idea. Use the reciprocal. Very good. What definitely do I not want to do here? What is never going to be okay to do? Just as a little aside, what's not okay is to try to say this. Exponents do not distribute. So this is never allowed, never okay to do that. if you're like, wait a minute, Mr. Kulik, you did something like that earlier. Well, this is something that is okay. A times b is a to the n times b to the n. But it does not work for multiplication, or I'm sorry, for addition or subtraction. In the business, we call this guy the freshman's formula as a pejorative, kind of insulting title to it, because the kinds of people that make this mistake are freshmen, not experienced mathematicians. But that's an important distinction to make there, the difference between addition and multiplication with how you apply that exponent. Okay? So just as a little aside, but very good, Sierra, to think that we're going to just use the reciprocal and not try to distribute anything. That's good instinct there. So I'm going to get x plus 3. And then do I need a plus or minus here? Well, what kind of root did we use to both sides? Even root. So we definitely need the plus or minus here. And 4 to the 3 halves is 8, in case you're curious. Okay. Now what? Yeah, so if I subtract 3 from both sides, what do we get? Do I get plus or minus 11? No, right? I have to write this as negative 3 plus or minus 8. So when I split that up, if I do negative 3 plus 8, I get 5. If I get negative 3 minus 8, I get negative 11. Do I need to check these answers? Well, if I go back and I look, what kind of radical did I have in the original problem? Odd. Do I need to check it? No. So these are my two answers. Okay. We're going to stop here for today. We'll do some more solving problems next class and maybe even the class after that.